Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is a lecture on IR spectra and this is lecture number 3. In this lecture, I will explain introduction to IR spectra. In every stable molecule, we have seen that atoms continuously vibrate between R1 and R2 distance in ground state. This is known as basic vibrational level V0. As for example HCl, this we have seen in previous lectures. In HCl, there is a covalent bond which is polar also, so we consider these as covalent polar bond and has definite dipole moment. You know dipole moment is mu, which is equal to E into R, charge into distance, and the unit is dvi. When such polar molecule absorbs infrared radiations of particular frequency, atoms start vibrating vigorously. That means molecule transit to higher level, higher vibrational level. If ground state level is V0, then we can give this label to V1 and start vibrating from R1 dash to R2 dash distance. Okay. So now there will be new distance between them. This molecule start vibrating. As IR radiation is absorbed for this new vibration it gives a signal which produces a band or a dip on a graph paper known as IR spectra. Okay. So this band includes all rotational transitions along with vibrational transition. Therefore, IR signal appear as a band or a dip instead of lines. This is due to rotations as well as vibrations, change in rotational as well as vibrational levels. So the IR spectra is also known as rotational vibrational spectra. Rotational vibrational spectra. Okay. So organic molecule contain many polar bonds between different non-metal atoms like the bond between carbon and hydrogen, carbon and single bond oxygen, carbon and double bond oxygen, carbon and single bond nitrogen, carbon and double bond nitrogen, carbon and triple bond nitrogen, oxygen and hydrogen, carbon and halogen, nitrogen and hydrogen, etc. When such organic molecule absorbs infrared each polar bond absorb different IR radiations because they have different types of atoms, and that is very important because their frequency will be different. So at the same time, what happened? Bond polarity changes due to change in distance between atoms. Therefore, different polar bonds absorb different IR radiations and transfer to higher vibrational levels. Therefore, all these different covalent polar bonds produce band with different frequencies in the range of 4,000 to 600 centimeter inverse. Therefore, IR spectra is used to identify presence of various polar bonds associated with different functional groups. So this becomes a main application of infrared spectra. So our main application is to identify a particular functional groups present, particular functional groups present in a given organic molecule. And for example, if any compound has carbonyl group with ketonic subgroup, irrespective of rest structure of molecule, we get bands at a definite frequency which confirm the presence of carbonyl group. So this is what we want to know about any molecule. That's it in this lecture. Thank you.